look like you're so ice, ice, ice. You won't make it to the finish line. Nope. Now if you gotta know the truth, was gonna let you go. You was fine, never mind, unpredictable. Feet out of the ground, you ain't no one. You a star, blew it up like supernova. In the nighttime, hit a hotline. Sharing secrets, you was really was part your life. Basic bullets, with no bullets. Does your wifey know you're begging for my notice? Promise you're the same, running for the magic. Show you like my vibe, pass my candy on my wrist. Bad habits, little rabbit. Now sit down, you can have it. I see it when you walk my way. Nice big bed, come and play with me. Freak it dog, freak it dog. Got a whole lot of love for my dog. I see it when you walk my way. Nice big bed, come and play with me. Freak it dog, freak it dog. Now show how freaky you are.
So I'm just gonna be away for 1 hour. Please don't break anything. And I might have a surprise for you.
Give me a miracle. I need a syllable. Talking about big cash, that's the minimum. I'm done with this trash. Talk to me critical. Show me your mental state before we get physical. Pour some water in your cup, let it drip, drip, drip. Now look straight into my eyes and you sip, sip, sip. It's about time, let you shine. Take off that leash so that we can have some fun. I see red when you walk my way. Nice big bed, come and play with me. Freak it dog, freak it dog. Got a whole lot of love for my dog. I see red when you walk my way. Nice big bed, come and play with me. Freak it dog, now show how freaky you are. I see red when you walk my way. Nice big bed, come and play with me. Freak it dog, freak it dog. Got a whole lot of love for my dog. Freak it dog, freak it dog. Got a whole lot of love for my dog. Freak it dog, freak it dog. Got a whole lot of love for my dog.
Hey, hey, hey. G'day, everyone. Here we are back again Another Toolbox Tech Talk.
I don't need to analyze every word that comes out is a lie. Make you look like you're so ice. You won't make it to the finish line.
Yeah. It's great to be back on another sesh. So today I've got a very special guest I'll introduce in a minute, but just want to thank you all again for turning up to listen to another Toolbox Tech Talk here at the Smart Energy Lab with the Smoke Machine and with Tunes. Well, it's been a big week here. A big week of rain, actually. So those who happen to live in Australia will probably know we've had the classic drought and floods all at the same time in different parts of Australia. So here on the East Coast, particularly up north, northern New South Wales, they've had massive rains. It's made its way down here to Melbourne. And we've been struggling a little bit with power. When it rains, we don't get so much solar, and we are 100% off-grid here at the Smart Energy Lab. So we've been hurrying to cobble together our new big battery. So we've got a almost 1 megawatt hour battery system to run our microgrid, and we've been sort of building it as the weather's been getting worse. We've finally got part of it online, so that's been really a great achievement. Other news, look, the battery rebate, which starts on the 1st of July in Australia, is still the hottest topic in the industry at the moment. People are trying to get their head around all the details. Will it be stackable with other rebates from state governments as well as the federal rebate, particularly those in New South Wales with the PDRS and those in Western Australia with their rebates? It's going to make battery storage really, really affordable. We're seeing, at least a 30% reduction, maybe even more in the cost of a storage system. And it does go up to a 50 kilowatt hour subsidy, so pretty big amount of storage with a maximum capacity of 100 kilowatt hours. So we'll see the commercial and industrial market picking up on this as well. So we expect to see a lot of battery systems go in. I mean, the government's pitch is they want to see 1 million battery systems installed over the next 5 years. And that's going to help with grid stabilization, soaking up all that surplus solar that Australia's massive rooftop solar is generating every day, which has now become a problem. It's a problem for stability for the grid. But when it comes to batteries, there's still a lot of concern about what technology, what's the best in terms of reliability, in terms of longevity, in terms of safety. And that's kind of where my guest comes in. Their technologies are going to be something I'd like to discuss with you. So I'd like to introduce, here we go. G'day, Billy.
Glenn, thank you very much.
So this is Billy de Jong from Wright Energy, I always get the name wrong, Wright Energy Storage Technologies in South Africa. You're commonly called West, W-E-S-T, on your products. So I see it on your T-shirt there. It's quite a mouthful, the full name, but yeah. So is that a founder's name, right?
Yes, it's my partner Chip is strangely enough far related to the Wright brothers. So yes, he came up with a name, and it turned out to be West. If it wasn't intended to be called West, but that's what it ended up being.
Do you mean the Wright brothers of aeronautic fame?
Yes, that's the Wright brothers I'm referring to.
Wow, that's quite a connection.
Yeah.
Cool. So you are the Chief Technology Officer there at Wright Energy Storage Technologies. So what does a CTO do on a day-to-day basis?
Glenn, in our business, it's a pretty hands-on role. For myself, we basically I would be working with the engineering team at least two to 3 days of the week. I would be helping the marketing staff come up with what their plan and execution would be. And then I'd also be part of the sales, the sales cycle. And so it's a pretty hands-on job. Predominantly, I would say my main role would be focusing on, the technology and, which direction, we're going to design, looking at working with the sales guys. We get sort of a need for the market penetration that we need, and then I try and execute that with the engineering team.
Well, I guess people are wondering, what is this technology? So maybe tell us a bit about what you actually make.
So, Glenn, just to summarize it, it's basically static storage, which is the got the benefits of the static storage, but a little bit more energy dense than the typical pure EDLC capacitor. So it's a really safe, high power product, and it's got a very long lifetime, similar to capacitors, and so that's in a nutshell.
Well, I have to let everyone know I've actually got a couple of your units here at the Smart Energy Lab. I've had them for quite some time, and we've been playing with them on a Victron system. It's been very interesting. It's a curious looking box, basically. I haven't got a picture to show people at the moment, but a blue box with sort of magical powers inside.
Yeah. We try to keep the look and feel simple. The look and feel basically comes from the marketing team. So we try and keep it as simple and straightforward as possible.
And as a energy storage device, I guess one of the things people ask about is what would it work with? So we're using a 48 volt Victron system here. What would your device work with?
Glenn, you can couple it with most inverter types. By now, I think we've worked with pretty much all the inverters on the market. The Victron, system that you've got works very nicely with the Supercap, but you can use it with any type of inverter system.
So it doesn't need any special communication protocol to talk to the inverter?
It doesn't need any special communications, no. So all the safeties are built in, and all the communication and monitoring happens directly, like you've seen directly from the cloud. It's got its own direct Wi-Fi communication, and pretty soon we're going to have Ethernet on there as well. We are putting CAN bus on there, so the devices that we're working on at the moment, the engineering team is basically communications with the inverter, but that's purely for auxiliary. So
Now, we haven't really talked about chemistries. People refer to this device as a Supercap. Is that correct?
Yes, it is part of the Supercap family. If you look at the Supercap, it's got a couple of branches under the family tree, which includes hybrid capacitors, EDLC, pseudo ultra capacitors. So it's one of the. It's not an EDLC, so it's one of the hybrid pseudo / ultra capacitors. It's something in that mixture. Of the capacitor family, so it's got the higher energy density, than EDLC, but it still has the static properties. It's not a lithium, so yeah.
Right, that's a key point. It's not a lithium battery called a supercapacitor.
Yes.
I'd love to expand acronyms. What was the acronym you used? EDLP.
So EDLC, so electric double layer capacitor. That's when people refer to capacitors. I think that's the one that sort of comes to mind for most people. So that's a linear charge and discharge capacitor. We're not quite just a EDLC.
Right. So typically, an EDLT would be a can-shaped capacitor with foil wrapped around with a dielectric between the two layers, and it's storing charge.
Yeah, Yeah, so EDLC
Yeah.
is a pure carbon capacitor. So it doesn't have any attractor layers or enhancing the carbon storage. So those are the typical capacitors that you see on a straight linear line, charge and discharge. Super powerful, but not very energy dense.
And I guess the other problem is, as you mentioned, it's a linear relationship between state of charge and voltage. So it makes it difficult to utilize the full capacity when you want a constant voltage source.
Exactly.
Now, with your technology, do you have to deal with a wide range of operating voltages as it's charging and discharging?
Glenn, luckily not. So our operating range is actually quite a lot smaller than you would find with with lithium. So we've got a very stable operating range for a 48 volt system. We typically operate. All the energy is going to come out from 53 volt down to 46 volt. That's it. So that is our operating range, and that's where the rated capacity comes out.
Right. Now, the units I've got here have built-in Wi-Fi, so that's pretty cool. You can actually monitor it with the West app, and it reports the state of charge on the app. Now, how do you calculate state of charge when you've got a very flat voltage characteristic?
So, Glenn, that's one of the things that you've got to do is each unit has to do column counting. So you've got to have a shunt inside, and you've got to actually work on column counting. Because the voltage characteristic is quite easy to get that wrong.
Yes. So coulomb counting is typically done with external devices too, with a shunt, but you've built it into your unit. So amp hours in, amp hours out, minus efficiency. Yep.
Yeah, exactly.
That's pretty cool. Now, what are some of the other advantages of this technology?
So, Glenn, if when we started developing it, safety wasn't the main feature in mind. We were looking at longevity, a low cost of storage. Although the initial cost is a little bit higher than you would typically find with lithium. If you look at the overall levelized cost in life, supercapacitors is very low because it lasts a really long time. You can 100% DoD it. It's got a lot of advantages, in the cost, in the cost state. Lately, safety is becoming, I would say, let me rather put it as Chip would say, safety is number 1, 2, and 3 right now because, there's a big focus globally on safety. And, from our side, that wasn't the main focus, although it's probably one of the safest products around.
So what makes it safer than, say, a lithium ferrophosphate battery?
So there's a couple of things. Firstly, they supercap typically don't go into thermal runaway. You can pretty much if you go through your safety certification, they do penetration test where they put a nail through it. They would short it out. They would overvolt it. So overvolt is typically one cell charged to 25 volt. 10 times over the rating at maximum current. So all those tests are typically designed to, make a cell go into thermal runaway. And the interesting thing with Supercap is none of those tests get it into thermal runaway. Even the crush test, you can cut it up. It doesn't go into thermal runaway. So that's the first safety factor is the fact that it doesn't go into thermal runaway. And then if they do ignite it, so let's say they take a flame or some heating element or something, and they do get it into a burning state, it only burns at about 600 degrees Celsius for a few seconds, which is the electrolyte that's flammable. So you can extinguish it with water. Any fire extinguishing would work as well. And the last test that I think is relevant here is you need more than 600 degrees Celsius to actually melt the casing and keep spreading the fire. So that is what the safety guys call non-propagating. So if you put two units next to each other and you ignite the first one, it won't actually, the fire won't, propagate to the adjacent unit. So, yeah, and for those, for those factors, plus the fact you can put it out with normal fire suppression, you don't need any specialized, fire suppression. It's a pretty safe product.
Yeah, I think safety is becoming a much bigger concern for regulators around the world. I know here in Australia, we were sort of rushed to get out a standard for energy storage, which we call ASNZS 5139, but it's very focused on the residential applications. It doesn't really have much to say about non-residential, like commercial applications. I know in the US with NFPA 855 regulations, it's really stringent for commercial, like, exposure sites have to be greater than, I think it's 10 feet or something, or everything's in feet. So you've got to have, if you put one in a shopping centre, you'd have to have a blast wall around it, basically. And now your colleague Peter Schmidt just published on LinkedIn something about the Dutch hazardous substances regulations, PGS. I can't remember what that number is. And that's really interesting. So it looks like the Dutch government have put in some pretty stringent guidelines for residential and commercial storage. So I think we're going to see this flow through to generally, other countries. So a technology that can sidestep some of those risks has got a big advantage.
Yeah, absolutely. We also only recently heard about the Dutch government's push to actually get lithium basically out of houses. So the regulation states that any battery storage or lithium ion battery storage greater than 20 kilowatt hours need to be 20 meters away from the closest building. So so that's it's an interesting, very interesting rule to come up with. So yeah, it's going to be interesting. The one thing that might count in our favor is that we actually classified as non-dangerous goods because of the safety certification. So it'll be interesting to see if they will allow us to be inside buildings.
For those who are interested in reading that Dutch standard, actually Google does translate it to English as well. It's PGS 37-2 2023, published in December 2023. So it makes quite interesting reading. So yeah, for those who are into the tech side. So advantages of your supercap technology is safety, it's a kind of generic in terms of it works with a whole range of inverters, or it can be DC coupled as well, so you can charge it from a DC source. It's got built-in monitoring, which I love. The West app, it's a great way to monitor it. But I also found just the interface. It took me, I had to read the manual, the fact that you use flash codes to identify, different functions. So once you get your head around the one flash, the three quick flashes, and then number of button presses, you can program it quite simply just with one button.
Yes, we try to make the user interface as simple and as robust as possible. Quite an interesting thing is a couple of years ago when we originally started, this project, we used standard off-the-shelf BMSs, and one of the things there's a couple of things that we found with the BMSs back then is typically if something goes wrong with a BMS, you've got to replace the whole BMS first. So what we've done is we've actually made our BMS modular. So if we have a remote site and something goes wrong with, say, the CPU card or the power card or a balancing board or something, then you can simply hot plug it, switch another one in, and we had to really think for a product that'll last really long, and capacitors have proven themselves to outlast other technologies with a long shot. We really had to think about the BMS and how we integrate it and how we change it compared to standard BMSs out on the market. So we ended up pretty much designing our BMS from scratch. to fit that purpose. So.
So speaking of longevity, what is the design life?
So, Glenn, at the moment, our longest units, and I want to say out there is 10 years and counting. Very, minimal degradation on those units. The design life, according to the guys, are anywhere between 35 and 45 years. So,
wow.
Yeah.
It's a lifetime purchase.
Yeah, and that was the challenge for the engineering team, to come up with a BMS that we know that electronics is just electronics, right? It's not going to last 45 years. So we had to make the electronics so that you can upgrade it, field service it. We had to look at our warranty and service policy, because you don't want to ship the thing every time a BMS fails. You want to ship it back to the factory. So we had to design a BMS from scratch that is field replaceable. And the standard user can sort of do and make it so that it's robust and easily to replace.
That's an interesting problem, because usually the concern is how long will the cells last, but you're worried how long will the BMS last, because the cells can last so long. I mean, I don't know if you have electrolytic capacitors in your BMS, but the lifespan of those is often a concern.
Yeah, we try to limit the electrolytic capacitors, and another design features, we had to derate all the MOSFETs and the stuff, quite significantly, to try and get more life out of all the hard working components. So yeah, we try to minimize anything that could cause damage, and if they can, if there's components that could fail, we try and separate them onto a couple of boards, so that if they fail, we can just replace those instead of the whole BMS.
One of the challenges I have here at the Smart Energy Lab is I get a lot of energy storage products sent here, and they don't all get used all the time. So some of them go into storage, and occasionally I've got a lithium battery that's been sitting in storage for 2-3 years, and I get it out and it's dead. I can't charge it, and it's probably even unsafe if I try to charge it directly. Is that a challenge for your product?
Not at all. So we often, when we manufacture, our manufacturing process actually requires us to 0 volt the capacitors, and we then take them through a solder bath. And it's capacitors don't mind going to 0 volt. We were also at one stage when we were flying the modules, because they're capacitors, they are cleared for air travel as non-DG. So at one stage, the guys were quite skeptical about them, and they required us to actually take them down to 0 volt, short out the terminals before we load them on a plane. So, and that's not a problem. You can do that. You can leave them on 0 volt for a couple of years and then charge them up, and they're fine.
Wow. That is a big plus. So yeah, you could put it on the shelf and just get it off when you need it, and it's not going to be dead. So yeah. So just looking at my list of questions that I've got here for you. People often ask me when I talk about energy storage, they go, what do you do at the end of life? You've got this, let's say you've got a lithium battery. We know that it's pretty difficult to find anyone who can recycle that in a sustainable way. Mostly it's just scrap. And it's hazardous scrap because you crush it and it catches on fire in your machinery. What's your approach to end of life for your device?
So, Glenn, it's a lot easier to actually recycle capacitor. The beauty of it is you can open it up, so you can crush it, you can penetrate it. You're not going to have any fires, any shorts, pretty much anything. So it's a lot easier to recycle. The main energy storage component is actually carbon. So like any other capacitor, so that's it's pretty safe. You can get the carbon, try recycle the carbon. I think we haven't had to deal with any recycling issues yet. Cross our fingers, but I think when we do, it's pretty much because of the carbon. It should be, as a high percentage, maybe in the 80s, recyclable, and it's not dangerous. So to recycle it.
Well, with a design life in the 40 plus years, you've got plenty of time to think about a solution.
Yeah.
And as you point out, the fact that you can actually take it to 0 volts means it's not an energy device. It's got no energy in it, so it's perfectly safe to be crushed or processed in ways which would not be possible with a conventional lithium cell.
Yeah, absolutely.
Now, the products I have here, I think they're 3.4, 3.3 kilowatt hour units from memory.
Yes, that's our smallest one. So 3.3. The middle one is a 5.0, and then we've got a 6.5.
Right. Now, if you have more than one of them, just parallel.
Yeah, something interesting which you can't really do with other technologies is you can also mix and match sizes. So you can parallel a 3.3 with a 6.5 with a 5.0, no problem. So they all work together.
Will they track together at the same state of charge?
Yes, the state of charge would basically, the current split would be pretty much even, and that's controlled. I would say not controlled. That is as a result of a very low internal resistance. So the state of charge is gonna track pretty much even.
Wow! So you don't have to all the same, which is a plus for upgradability, because products that I've had here at the lab, sometimes, I've said to the manufacturer, so this is about 2 years old, this product, and we want to add some more storage to it. Can we add another, unit on top? And they go, oh, we don't make that anymore. The only choice is to throw it away and start again. But you're saying you can just add your latest products onto your older products.
We've got a lot of sites out in Africa and South Africa where people install generation 1, which is 2015, 2016, and as they need expand and a lodge grow or a house it gets more load, that's the way it goes. They can just add on at any point in time. So we've got products that are 10 years old working with products that is a couple of weeks or months old. So yeah, it's a very nice feature that you don't have that sort of time limit to expand.
Right. Yeah. So it's nominally a 48 volt unit. Do you do any other voltages?
So yeah, we do, Glenn, a unit that goes up to 480 volt. Sorry, so 480 is like a stop for us on the one specific product, but we go up to 860 volts. 480 is quite interesting voltage. We make a product specifically designed for high discharge applications like data centers, or where you've got to transfer from the grid to, let's say, a diesel generator or other backup sources, and that product is designed to go up to 5C. So yeah, it can run 5C continuous for the whole duration, so 12 minutes, no problem. And yeah, we can go up to 860 volts.
Wow, we hadn't talked about the C ratings. That's incredible. I mean, most lithiums, charge at 0.5 C and maybe discharge at 1 C. You can do 5 times better.
Yeah, and the beauty is we've got a couple of thousand cycles in our factory in Bloemfontein, South Africa. We actually, we test the cells and the capacitors, and we've got a couple of thousand cycles at even at 5C with no issues.
So your product can be used, in on-grid and off-grid applications.
Absolutely, yeah. There's a lot of off-grid applications. Strange enough, people would think capacitors wouldn't really be suitable for for off-grid because of self-discharge. But the beauty about the capacitors we use is they've got a very low self-discharge. You typically lose the energy over a couple of years. And yeah, they work perfectly well for off-grid, and the fact that you can upgrade them as you need makes them perfect for those kind of applications.
Yeah, cool. So tell me a bit about your company. You're based in Bloemfontein, is that right?
So the engineering office where I'm located is based in Stellenbosch, a little technology park there. And we've got, that is our main engineering office. We've got our cell research team out in Maine in the USA. Our head office is in New York. That's where, our financial and the CEO, they in that office. And then, I'm driving the engineering team in Stellenbosch, as well as the marketing team is located in Stellenbosch, and procurement and a couple of other things. And then we've got the factory in Bloemfontein. So that's where the rubber hits the road.
Wow, quite an international spread. I hadn't realised you had a New York office as well.
Yeah.
So your product is available internationally?
Yes, Glenn. It's so we are finishing up the last little bits of certification for both ULCE, and then once we've got that, we obviously going to continue and get the CB certification. We're also busy with another certification called Lloyd's Registry, which is a marine standard requirement, because the guys on the yachts find Supercap, and the safety that it brings, quite interesting as well. So we're busy with all of those things at the same time, and we've got a couple of tests left, for ULCE, CB, and then obviously Lloyd's. So
which UL are you testing to?
So there's a couple of UL standards. The obviously on cell level, it was UL 810A, which is a capacitor standard, and then because we energy storage device, they said it would be best if we do 1973 and all the others that lithium typically conform to. So to test the BMS. So we'll have a lithium grade BMS on a non-hazardous, non-dangerous goods capacitor product. But so we've got the best of the safest of both.
Wow, so UL 1973 is a pretty tough safety standard. So I like the fire test in that, where you put it in a pool of hydrocarbon and set fire to it for 20 minutes.
Yeah.
And what about IEC?
Same, so 62619. There's a couple of others, pretty much the same. We conform to the same standards on the IEC side. I think it's just a couple of derated values that IEC, have according to UL. So we actually run the test hand in hand on the UL side and the IEC testing. So it's pretty much the same testing on both sides.
Cool. Now, have you integrated with any partners with your products, so embedded it into other products?
Glenn, not yet. We are speaking to a couple of interesting larger players at the moment. Siemens is, we spoke to Siemens quite recently. They've got some interesting applications. Schneider's on the really larger stuff. So there's a couple of interesting integrations that might happen on grid side, grid level storage. But we haven't partnered with any specific inverter manufacturers or anybody like that yet.
Right. Now, I'm curious, how did you come to want to use supercaps? I mean, is this the basis of the business, or it was just a product that you developed?
So, Glenn, it's an interesting story. Back in 2012, I was sort of teaching short courses on system design, and one of the interesting parts of the class that I gave the guys was how to calculate the cost of energy storage. So I'd come up with a pretty decent calculator to work out life of batteries. Back then things were still quite simple. Lithium ion had just come onto the horizon, and for storage, and we were using lead acid mostly, and I was playing around with with the calculators. And when we went to Abu Dhabi once, on a technology show, we found this supercapacitor idea. And I although it was really expensive back then, in the $1,000+ per kilowatt hour, I pulled it into the life calculator, and I saw, but hey, hold on, the fact that you don't have to compensate for degradation, and the fact that you can cycle at 100% depth of discharge, and all of those other factors made it really interesting when you put it into a system. So we started dabbling with that technology. Around about 2014 is when we started looking at it, and then we obviously had to first prove that this technology can do what it says. So that took us a year with our testing and so on. And then we started proof of concept, and we evolved the product from there. In 2020, I got together with Chip, and we said, look, let's take this product to the next level, where we had to develop our own BMS, because for obvious reasons, BMSs were failing us after a few years. And we had to develop that from scratch, and that's how it materialized. In the last couple of years, I think safety is a big buzzword for everybody. But when we looked at it back in 2012, it was just a additional benefit, not something we actually put any focus on.
Right. Yeah, I'm familiar with different models for total cost of ownership for energy storage. Often it's based on things like energy throughput and warranty. Speaking of which, what is the warranty on your supercaps?
So Glenn has got a 20-year warranty. The BMS is warranted for 10 or 12 years. I'll just double check on the paperwork. So the BMS is 10 or 12 years, but you can actually purchase the broken down components. So you don't need to purchase an entire BMS if let's say a power board or something with an electrolytic cap backs up a few years, in year 15. You can actually just look at those. But the product warranty, the performance warranty, is 20 years.
Wow. So a 20-year lifespan for the supercaps, 10 to 12 for the BMS, which is a serviceable item. So a bit like your car, you've got to look after it. Some things will wear out. It's great that that sort of component means it's not a throwaway product. It's virtually a lifetime product.
Yeah.
Yeah. Wow. What was I going to ask you about? So it was your experience with the product from the Abu Dhabi exhibition. I think it was a Saudi company, wasn't it, from memory? And you could see that the technology had its merits in terms of longevity and cost of energy storage. But now you've got the bonus that you've also got one of the safest energy storage products available, because you're not using lithium, which lithium ferrophosphate or NCA or NMC, which is now the scary thing to have hanging on the side of your house if anything goes wrong. I guess that's a boon. So with a product with that kind of lifespan, I guess your company's got to be around for a long time to support it. That's got another question, I suppose.
Yeah, no, absolutely. We've been field testing, and we've installed about 35 megawatt hours into Africa, and quite a couple of megawatt hours around the world. And if you look at the feedback and the actual product operating, we've had very minimal problems. One of the features that very few people are familiar with is the moment that you put the unit online, we actually monitor the unit on your behalf. So all the units that are connected to Wi-Fi or Ethernet or whichever is monitored by us, and we can actually inform you before something goes wrong. We can see that a part of the BMS is packed up, or the cells are starting to drift, or whatever the case is, and we could actually we can actually take preventative steps to before any damage is caused. So that's another feature that very few people are aware about, and which is a cool thing for us to actually make sure that the product lasts a really long time.
Wow, that's cool. So yeah, you've got oversight on the longevity, safety aspect of the product by just connecting it through to your cloud service. So yeah, I guess we're sort of winding things up here. And one of the questions I usually like to ask anyone on this channel who's certainly in the engineering space is, what advice would you give to young and emerging engineers in terms of the development for energy storage? What should they be looking at?
So I think energy storage is a really interesting market, and there's so many opportunities in energy storage that the guys can enter. It's if you can join a team that develops stuff, it's really exciting. I think it's one of those jobs where in some days you've got to chase people away from the office, kind of so it gets really exciting. So yeah, it's and you get to play with a lot of cool stuff. We've got really cool technology out there, and it's definitely, I think, in my opinion, one of the more exciting jobs that you can be in.
I guess, from a renewable energy perspective, I mean, solar has had its day. I think solar now is a very generic kind of solution out there. It's also very hard to get into then from an R&D perspective, the cost of it. But when it comes to energy storage, I mean, you can go down to your local electronic shop and start dabbling with, your own BMS, your own cells, and making a new product.
Absolutely. I think there's a lot of research that must still happen in the capacitor space. I know a lot of money has been pushed into lithium ion, into the lithium ion space, and development around lithium ion. And I think if you look at the money that's gone into capacitors, it's a fraction of that. So I think there's a lot of interesting developments up and coming, and also the material science guys. I think to focus on the capacitor side could be very interesting.
Indeed. Well, Billy, thanks very much for talking to us here on the Toolbox Tech Talk, and hope you enjoy the rest of your day.
Glenn, thank you very much. It was very nice talking to you, and thanks, and have a great day there.
Okay, right. See you, Billy.
Thank you. Bye-bye.
Well, that's another Toolbox Tech Talk under my belt, and thanks for watching, everyone. Now, next week, I'm possibly going to be on the road on Sunday, so I'm not sure whether I'll be doing a Toolbox Tech Talk, but I'll do my best to kind of get in front of a camera and a microphone and see what can happen. But otherwise, until then, keep safe and enjoy yourself. Check out. See ya.
Every word that comes out, he's a